Have you ever thought about what it would look like if a whole team of AIs could work together to solve problems we can't even touch? Well, that's not science fiction anymore. It's happening right now. And in this explainer, we're going to pull back the curtain on how these autonomous agents actually talk, coordinate, and team up.
So, here's the game plan. We're going to start with the fundamental challenge of getting AIs to cooperate. Then, we'll take a little trip back in time to the very first languages they used. After that, we'll see how a modern AI company gets built. Watch how these agents actually make deals, and finally, we'll look ahead to the massive task of building an entire AI economy.
You know, a single AI can be incredibly powerful, but getting a whole group of them to work together? That is a massive, massive challenge. I mean, how do they delegate tasks without stepping on each other's toes? How do they avoid misunderstandings? How do they even build trust? That's the big question we're diving into today. To really wrap our heads around all this, we're going to use a simple but honestly super powerful metaphor. We're going to think about a team of AIs not as a bunch of code, but as a company.
Now, the official term for this is a multi-agent system. From here on out, whenever you hear that phrase, just picture a company where every single employee, from the CEO all the way down to the intern, is its own intelligent, autonomous piece of software. This one idea is going to be our guide for the rest of this journey.
So, what's the very first thing any new company needs? Well, you need a shared language and a rulebook for how to communicate, right? It was exactly the same in the world of AI. The first step was designing the very first languages for agents to talk to each other. And pretty much any language, whether it's for humans or machines, has three basic layers. First, you've got syntax. That's just the grammar, the structure. Then there's semantics. That's the dictionary, making sure we all agree on what words mean. But the real magic, the most important part, is that third layer, pragmatics. This is the intent. It's the difference between saying, the window is open, as just an observation, versus saying it because you want someone to close it. And this whole idea actually came from philosophy, from something called speech act theory. The core idea is that language isn't passive. Language is action. When an AI agent sends a message, it's not just spitting out data. It's actively doing something. It's making a request, giving an order, or even making a promise. So this led to two of the first big languages. The first one, KQML, was, well, a little invasive. It let one agent just directly edit another agent's memory, kind of like a coworker reaching over and scribbling all over your private notebook. The next generation, FIPA ACL, was way smarter. It respected that each agent was autonomous. You couldn't just change another agent's mind, you had to send a formal request and try to persuade it. You know, much more professional. But look, these early languages were a product of their time. They were super complex, pretty rigid, and just not built for the fast-paced, dynamic web that we have today. They weren't absolutely brilliant first draft, but it was obvious a new approach was needed. Because of those limitations, the whole architecture had to be rethought. As our AI company metaphorically grew, it realized one giant, complicated rulebook was never going to work. No, it needed specialized departments, each with its own simple, focused set of rules. And that's what led us to the modern era of the protocol stack. First up is the tools department. An agent has to know what it can do, which databases to query, which APIs it can call. The Model Context Protocol, or MCP, is basically the company's internal wiki and its tool playbook. It gives every agent a crystal clear map of its own capabilities. Okay, so agents know what they can do. Now they need a way to coordinate with each other. That's the job of the Agent Communication Protocol, or ACP. Just think of this as the company's internal Slack or email system. It's a straightforward channel for sending messages and divvying up tasks. But wait a second. In a company with potentially millions of AI agents, how in the world do you find the right one to talk to? Well, you'd use the Agent Network Protocol, or AMP. This is the HR employee directory. It's how an agent can discover other agents, check their ID, and set up a secure line of communication. And this is just a brilliant way to see how it all fits together. It's a stack of specialized layers. At the very bottom, an agent uses MCP to understand its own tools. In the middle, it uses ANP to find other agents out there. And then at the top, it uses ACP to actually work with them. It's this flexible modular design that is so powerful. Honestly, it's a lot like the TCP/IP stack that runs the entire internet. All right, so our agents have their language, they have a way to connect. But for real collaboration, for real teamwork, they need something else. A set of social rules, you could say. Standard procedures for how to get things done together. These are called interaction protocols.
And think of it this way. If the communication protocol is the company's email system, an interaction protocol is like a pre-written email template for a request for a quote. It's a predefined pattern for a conversation that makes everything predictable. It's like a script for a meeting, where everybody already knows their part.
One of the most famous of these is called the Contract Net Protocol, and it's just a simple, beautiful, market-based way to assign tasks. A manager agent announces a job needs doing. Then, contractor agents look at the job and submit their bids. The manager picks the best one and awards the contract. And finally, the winner does the work and reports back. Simple, efficient, and totally decentralized.
And this isn't just theory. This is used in the real world today. Just imagine a smart grid on a really hot day. The main grid agent announces it needs to cut power usage. Your home's AI agent could then bid, "Hey, I can turn down the AC for 15 minutes for 50 cents. What's so revolutionary here is that no one single person or thing is controlling everything. It's a market. The whole system balances itself dynamically based on thousands of these tiny, independent economic decisions. That's the real power of this approach.
So, we've built our AI company. It has its departments, its communication tools, its meeting rules. But the ultimate vision here is so much bigger. We're talking about a global economy of autonomous agents. And to get there, we have to face some absolutely massive challenges.
First off, scalability. In a network with millions or even billions of agents, the number of possible connections is astronomical. How do you manage that without the whole system grinding to a halt? Then there's security, a huge one. In an open network, how do you trust that another agent is who it says it is, and not some bad actor trying to game the system? And maybe the trickiest of them all, governance. When a team of autonomous agents makes a mistake that costs a company millions of dollars, who's responsible? Who's accountable? These are the huge, complex problems we have to solve to build this future.
Which really leaves us with this one final, powerful thought. We are, right now, laying the foundation for a global economy that will be run by autonomous software. As we build it, the most crucial question we face becomes, who gets to write the rules? It's one of the most important questions for the future of technology, and frankly, one we'll all have a stake in answering.